Hi, ladies and gentlemen. We are looking at page 3 of our notes. They are on experimental probability. Bear with me. We just have some vocabulary that we have to define first before we do anything else. The first thing we need to do is actually define what the word probability means. And probability is just a measure of the likelihood. In other words, a measure of the chance an event will occur. Okay. A trial is just one round in a probability experiment. An outcome is a possible result of an experiment. So for example, if I were to flip a coin, my two outcomes are either heads or tails, right? So those are my outcomes in that experiment. Okay. An event is a set of outcomes with the same results. So an example of an event is actually getting heads, right? Like if I get heads, then that event has occurred, okay? And then frequency is just the total number of outcomes for an event. So, for example, if I were to roll a die, and I ended up getting I end up getting the number 2 5 times, then the frequency is 2. Okay, so rolling a die, get the number 2 5 times. This 5 is considered the frequency. It's how often something happens. Okay. So the next question, where's probability used? I'm not going to answer that question for you. I want you to think about that question. Think about it, pause the video, fill in what your answer is going to be, and then we'll discuss this next time I see you guys in class. Okay? So the next thing I want to talk about is what kinds of numbers you get for probability. So probability is the possibility of any event. The smallest possibility you could have, the smallest likelihood you have is 0. It means it's not going to happen. So probability is going to be a number between 0, meaning not possible, all the way to 1, meaning you have a 100% chance of it happening, so this is a certainty. Okay, and you can write your probabilities as fractions, decimals, or percents. All right, so experimental probability is determined using the results of an experiment. So how do you find the experimental probability of something? Well, first of all, our notation here is saying the probability of an event. So we always have P, and then in brackets, we have whatever it is that we're looking for. And I'll show you some more examples of this as we actually look at specific examples. But essentially, the probability of an event is just the number of successful trials over the total number of trials. okay? So once you get that down, don't forget you can pause and rewind if I'm going too fast. Take it at your own pace, okay? So an example of that is example 1 right here. You've got two 6-sided dice, and they were rolled 20 times, but doubles were rolled 4 times. So determine the experimental probability of rolling doubles. Express your answer as a fraction in lowest terms, as a decimal, and as a percent. So first thing we're going to do is we want to write down that we're trying to find the probability of getting doubles. So this is our notation. This is how you write the probability of getting doubles. And it's the number of, like we said before, successful trials over the total number of trials. Okay, so here our successful trials, we know that we got rolled doubles 4 times in our experiment. So the experimental probabilities numerator is going to be 4, and it was out of a total number of 20 trials. Okay, so then I have to write out what this is as a fraction in lowest terms. So here's our fraction, but it's not in lowest terms. I can divide both 4 and 20 by 4. So when I divide them both by 4, I end up getting 1 over 5. So the probability of doubles as a fraction is 1/5. So here's one part of our answer. But we also need to write our probability as a decimal. So what we're going to do is we are going to open up our calculator, and we're going to divide 1 by 5, because that's what this fraction is saying, 1 divided by 5, and we end up getting 0.2. We could also take 4 and divide it by 20, either way, and we still get 0.2. So the probability of doubles as a decimal is 0.2. Okay, which means that as a percent, the probability of getting doubles as a percent is just simply 20%, because 0.2 means 0.20, it's 20 hundredths, so it's 20%, because percent is always out of 100. Okay, now part B says write the probability of not rolling doubles as a fraction in lowest terms, as a decimal, and as a percent. Is not getting doubles. Okay, so we're going to say probability of no doubles is still the number of successful trials over the total number of trials. Well, this time, the probability of getting no doubles is going to be equal to, if there were 20 trials and 4 were successful, 4 were doubles, then 16 of them were not doubles. Okay, so we're going to say this is 16 right here, and it's out of the total number of trials, which is still 20. Now I'm going to see, can I divide them both by the same number? They're both divisible by the number 4 again, so I'm going to divide both by 4 to get it in simplest terms. So this right here is going to end up being 4 out of 5. And that should make sense to you, because if the probability of doubles is 1/5, then the probability of no doubles should be 4/5. So we'll say probability of no doubles is equal to 4/5. Now, as a decimal, I'm just going to take that number and I'm going to type it into my calculator. So I'm going to take 4, divide that by 5, and I get 0.8. Or I can take 16, divide that by 20, and I also get 0.8. So right here, the probability of no doubles is 0.8. Okay? And then the probability of no doubles as a percentage is 80%, because 0.8 is 80%. It's also 80% because if 20% were doubles, then the rest, the 80%, were not doubles. Okay? So example number 2 says a coin was tossed 30 times. The experimental probability of turning up heads was 2 out of 5. So how many times did the coin turn up heads? So this time our event is going to be heads. Okay? So if our probability of heads this time we're given the probability is 2 out of 5. We want to figure out how many times we actually ended up getting heads. So remember, we always do the number of successful trials on top. So out of, and we put the total number of trials on the bottom. So out of every 5 trials, 2 of them are successful. But this time right here, since 5 is total, we're going to make a proportion, and we are going to put the total number of times it actually happened, the total number of times we actually flipped the coin, which was 30. So that's going to correspond on the same part as the 5, so we're going to put the 30 in the denominator. We don't know how many times the heads actually turned up, so we're going to put X for the number of successful trials. Okay, now that we've gotten a proportion, all we have to do here is just simply cross multiply. So when I cross multiply here, 5 times X is 5X. And when I cross multiply on the other side, 2 times 30 is 60. Now to solve for X, just divide both sides by 5, so I end up getting X equals 12. Okay, that's one way to think about it. Another way to think about it is, if I simplify X over 30, I get 2 over 5. So to go from 5 to 30, we just have to multiply by 6. To go from 2 to X, we just simply multiply by 6. 2 times 6 is 12. So therefore, 12 heads was our outcome. Okay. Now, in part B, it says how many times did the coin turn up tails? So there are a bunch of different ways that we could do this. The first way we could do it is see that there were 30 trials altogether, and out of the 30 trials, 12 of them were heads, so the leftover is going to be tails. So we just do 30 minus 12, which is 18. So the coin, therefore, the coin turned up tails 18 times. Okay, and then part C, it says, what was the experimental probability of it turning up tails? Again, we have a bunch of different ways we can do this. We could say that the probability of tails, we've got 18 successful trials out of 30 altogether. Both of these numbers are divisible by 6. So when I divide them by 6, I get 3/5. So the probability of tails is 3/5. Another way to find out that the probability of getting tails is 3/5 is just to do 1 minus the probability of getting heads, because the total probability we could have is 1, and there are only 2 options, heads or tails. So if it's not heads, then it has to be tails. So we can just say 1 minus 3/5, and when I take away 3/5 from 5/5, I end up getting 2. Sorry, I should say 1 minus 2/5, excuse me, because the probability of getting heads was 2/5. So 2/5 taken away from 5/5 is 3/5. So either way, we'll get 3/5 as our answer. Okay? All right, example number 3, I want you guys to try on your own. So go through it, see how you do, and then we will talk about it next time I see you guys in class. You'll probably be working on it in class, so I'll help you out. If not, if you're doing this for homework, then you need to make sure you try it before you come to class tomorrow. All right, I hope you have a great day. Bye.